So here's an image of a furnace, an iron furnace. This is an abandoned steel mill from the end of the 19th century. It's in the Upper Peninsula of Michigan. It's about 6 miles from my cabin in the Upper Peninsula. And it's a state park, it's a historical park. And in this case, I took again about 100 photos of this scene. And I basically just walked back and forth in front of this building at a few different distances. And from those 100 photos, again, the computer program, the structure from motion computer program figured out where all the cameras were and where all the details of the scene were, and reconstructed a full 3D model. So you're seeing the perspective change because Arthur is walking around the room wearing the tracked glasses, so you're seeing his point of view of the scene. But it's a full 3D experience, both in terms of stereo and immersive surround images. But here, more importantly, you can walk anywhere in the scene. You can actually walk into that building and see some of the details near the entrance. And you can see the building from the right and the left. So over a fairly large area, you can move around and see the correct 3D point of view. But you still capture the kind of natural textures of this old limestone block building and brick building. For one of the applications for this, of course, is cultural heritage. This is a piece of cultural heritage from essentially the 19th century industrialization, where the Upper Peninsula supplied all the lumber for the Midwest and all the coal for the Midwest, or a lot of it, and also between the coal and the limestone and the birch trees from this area supplied the steel for the Midwest. So this cypress tree behind me was one of my first successful points acquisition with a camera, and this only took about 20 images, and it's from a cypress swamp in the Delta region of Mississippi. But what I like about this is that there's something that's captured about the texture of the bark of this tree that I find just amazing, and that's the kind of thing I'm trying to go after in essentially the art part of this technological investigation, which is how essentially I've never seen a virtual reality image with this kind of textural information, this kind of textural accuracy. So this is another points image. This image was acquired with different technology. This uses LiDAR, which is a device that sits on a tripod like a camera and scans the room with a laser beam and measures the time of flight of light to every position in the room. And it generates an image which is more accurate than the structure from motion images that I've been showing before, but has a couple of significant limitations. One is that it's a device that's so expensive that I wasn't able to take it to Saudi Arabia when I wanted to. And the other aspect is that there is some danger involved with it. You have to control people so that they don't actually get in the way of the laser beam. So it's a little more restrictive, but in certain environments it produces a higher quality result, especially in terms of measurement accuracy. So if I was charged with documenting some important piece of architecture, I would probably use this technology because I could take measurements and say the walls were exactly, 1.5 meters apart or something. The structure from motion, it's a little bit wobblier reconstruction of the environment. But what's important about this display is that I've also taken registered panoramas in this scene, so that now we can dissolve to a panorama within this house, and we'll be able to see it with the kind of photographic realism that the pans are good at showing. And so we can combine these two systems, so the point cloud system either captured by LiDAR or by structure from motion with the panoramic system to be able to, for instance, document an archaeological dig that can produce compelling images. And by compelling images, I mean images that can communicate the important aspects of the scene that we're trying to document.